All right, hey guys, we're going to get started here for the Rapsodo presentation. Just wanted to start by saying thanks for coming over. This is something we look forward to every year at the ABCA. Today is an exciting one. If you haven't had a chance to see us yet, we're at booth 400. We have presentations going in our booth throughout the trade show. What John and I are going to be covering is one of the exciting metrics at Rapsodo that we've ever launched. We're going to dive deep into that. But it's all about seam orientation and then how that affects seam shifted wake. So we're going to go into a quick overview of some of our new hardware, but very excited to dive into the topic of the seam orientation that's new at Rapsodo. So real quick, just a quick agenda of what John and I are going to be covering. Just a quick introduction of ourselves. We've worked with a lot of you, so it's great to see you guys at the booth and over here at the Expo Theater. But just a quick background. Like I mentioned, I'm going to cover our new hardware. So we're excited to launch our first ever stadium unit. A lot of you know us on the training side for our 1.0 units back to 2016 to the 2.0s on the ground. We've now launched a 3.0 that's dual pitching and hitting that I'll cover, and then also an actual stadium unit that is an installation at your stadium for any level of baseball. Then really the exciting, what we're going to cover with John as our expert on the seam orientation, that's really what we want to dive into. So that'll be the majority of the presentation is getting into those metrics. So myself, my name is Brian. I've been with Rapsodo from 2016, back when our 1.0 unit was on a tripod. So I was playing college ball at Anderson University up in Indiana. So my senior year, I was utilizing that 1.0 just on the pitching side to learn a little bit about my pitching just in that last year of college ball. So what I currently do at Rapsodo is I work with all of our Major League Baseball partners. So working with all 30 clubs. Also a lot of key accounts and partnerships for the showcases and tournaments out there at the youth level. So that's mostly what I do at Rapsodo, and great to see a lot of you that we've worked with over the years.
My name's John Garrett, and I'm an analytics engineer at Rapsodo. Been there since this past March. And before that, my background is actually in engineering. So I studied mechanical engineering at Utah State University. And in my lab that I worked in the experimental fluid dynamics lab. And if you're familiar at all with the term seam shifted wake, that came out of my lab at Utah State University. So I spent 3 years working in that lab as an undergraduate and as a graduate student researching seam shifted wake, and excited to talk about that today. Also, in the summer of 2021, I worked as an intern with Major League Baseball and helped them as they were rolling out their seam orientation data that they're now providing to MLB ball clubs. So excited to bring that to Rapsodo. So this slide right here, we just really like to highlight our current roster at Rapsodo. We've got the Insight camera, the pitching and hitting 2.0 products that a lot of you are hopefully familiar with, the Pro 3.0 and Stadium that we're going to talk more about today, and we're happy to talk more about in our booth as well, and then the Diamond app. And as you can see, we're widely used all across the spectrum from MLB teams through college and high school and academies, and really glad that you guys are here to hear from us today and hopefully talk to us again some more later.
Yeah, so just to get started, like I said, we're excited to dive into the seam orientation and the new metrics. First, if you haven't had a chance to see the information in our booth at 400, we have the new stadium. So I mentioned it earlier on. This is our first ever in-game unit. So the data points you're familiar with today on the ball flight. So on the pitching side, the velocity, spin rate, release information, spin efficiency, everything we do at Rapsodo, this is coming from the stadium unit, which is an installation on the stadium. So we will see these on MLB backfields, all levels of colleges, at high school level as well. Really, since day one at Rapsodo, the goal is to get pro level data to the hands of really all coaches at all levels. And this is a big step for us, getting that in-game data so that guys can get recruited to the college level, get recruited and scouted to the pro level as well. We know a lot of guys out there that are playing, a lot of hidden gems that maybe don't get data on them. What guys want to see at the next level is, the high intent, how do they perform in a game? That's where we can now provide that with our Rapsodo Stadium unit. This is just a quick look at that. Again, don't want to spend too much time on it because we want to get into the metrics. But this is really a custom installation to each field. What we've always been experts on is the optical side of the game, and then radar and our training tools. So our stadium unit is an optical tool that can be from 4 feet off of the ground up to 10. So we have an installation technician team that works with each program to get it customized to your field, depending on how far we are from a home plate. Then also just how the backstop is. We know all backstops are different. So it is a very light footprint installation to get it onto your field for that in-game data collection. You'll see on the corners of this slide is some video. That's actually the raw video that comes from our stadium unit. So we get a different angles. They are stereo cameras. So each camera does have 2 lenses that are tracking the ball from the pitcher's hand through contact and then ball flight. So you as a coach would get access to that video after to be able to break down mechanics, just utilize that video because it is cropped throughout the game. You can also turn on the stadium unit just for practice or sides out on the field. So it's not only in-game, but can be used for practice on your field anytime you're getting reps out on the field. I mentioned a little earlier, it is the data you're familiar with today. We have room to grow and add data points, but this is a look at what our stadium app would be. So it is ran by one person, one operator at the field, to where they can keep a bookkeeping so that you can tell the program that there was a pickoff move or there was a runner thrown out at second to keep the book throughout the game as the data automatically is being tagged to each player profile throughout the game when it comes to the analytics. So the things we do of spin rate, exit velocity, launch angle throughout each at-bat and for each pitcher so that, again, you get that in-game data. This is a look at what that app would look like. It just runs on a Mac Mini or a Mac that's provided with the system so that you can run it from the backstop, wherever that may be, to run the system. But it just takes one person to run that Rapsodo Stadium system. So something we're really excited about. Again, we'll be talking about this in the booth. So if Stadium does interest you, please stop by. It's the first year for it. So as you can imagine, there's a lot of demand throughout different levels of baseball. We've already installed some MLB backfields, a lot of different colleges. So if you are interested, please let us know, and we'll get you in line for that stadium unit for the next season. Also, just want to quickly touch on Pro 3.0 real quick before we get seam orientation. Hopefully, a lot of you are familiar with what we've done with the 1.0s and 2.0s. The 3.0 unit for training is the first ever that can do pitching and hitting at the same time. So there is inside of the Diamond app a session where you can see inbound and outbound. We're showcasing this at booth 400 throughout the show. It allows us to get triple the amount of images, which allows new data points. So release extension out of the pitcher's hand, then also contact depth, seam orientation, which we'll dive into. This Pro unit is more robust and is able to load faster. So getting the triggers for both pitching and hitting, just loading quicker. If you ever ran into any type of technology interference of EMI from the iPads, there is a direct connection through Ethernet. Then also the battery, we use it quite a bit for 6+ hours, even up to 8 hours. So you have a full day not worrying about charging the unit. So that's Pro 3.0. It's going to be utilized in the booth, so come see it when you get a chance. This, just to quickly touch, anytime we do have new hardware, we match it up and we validate it with the top provider at the MLB level. Currently today, if you're not familiar, that's Hawkeye, 18 camera solution in each MLB ballpark. So we're fortunate to work with our MLB clubs to get validations, and we naturally match up very well since we're also an optical system. So very exciting for the development of Stadium and 3.0. This we want to give a quick shout out just to our pro staff. They've been awesome in the booth. We've already had Kyle Wright and Mitch Keller. These are guys that utilize Rapsodo in their training in the off season and with their clubs. We got Sandy Alcantara, just fresh off the Cy Young Award last year. He'll be in the booth today at 4, I believe. So make sure you come see Sandy. But just want to give a shout out to these guys. Awesome having them in the booth. They're very open to the questions and answers. So very excited to have them here at ABCA this year. One exciting thing with Sandy is he's obviously a very dominant pitcher. This top left, is two-seam. He strikes out guys all year up in the zone with some run on that two-seam ball. Some of that can definitely be attributed to how that orientation is in the hand, which is new at Rapsodo this year. But just wanted to show this. He's got very exciting movement, obviously. But what John's about to do is kind of maybe touch on why that could be and how you could utilize that seam orientation, seam shifted wake in your own training in this upcoming season and off season.
All right, so again, my background is in mechanical engineering and in aerodynamics. So I'm not going to get too in-depth into the messy physics of it all. I'm happy to have more of that conversation if you're interested. But I'm going to try and keep it pretty understandable for those of you who maybe don't have a graduate degree in mechanical engineering. So like I said, I worked in the experimental fluid dynamics lab at Utah State University. And back in 2019, we were asked to kind of help try and figure out what led to the home run spike in 2017. And so in our lab, we had the capability to fire baseballs into an enclosure that was filled with theater fog. And then we had a system of lasers and cameras that are able to show us how the air is actually flowing around the baseball. And this started out as just us trying to figure out how the air was flowing around to see how that affected the home run spike. But it led to something a lot more interesting. And as we were doing this, we noticed that the seams had a bigger impact on how the wake formed on the baseball than we might have originally thought. So if you're watching here, you can see there's a blue and a red dot that kind of show where that wake is forming, blue on the top, the red on the bottom. And as the seams are rolling around, you can kind of see that that dot kind of follows the seams there for a bit. So this tipped us off that there's a range of locations on the ball where if a seam is present, it can alter where the wake forms. And this is important because that affects the pressure distribution around the ball. So I'm going to get into a little bit of physics, but not too much. So pressure is important because pressure leads to force that acts on the ball, right? And force leads to movement, okay? So I'm sure we're all familiar driving down the road. You stick your hand out the window. You can feel that pressure of the air running up against your hand. And if you change the shape of your hand, you can feel a varying amount of pressure, which leads to a different level of force that pushes your hand back or not so much. All right, so it's the same story with baseball. And the seams have a direct impact on the pressure that is acting on the ball, which again leads to the movement. So as we were doing this, we realized, well, if we can isolate this for the majority of the rotation of a ball, then we can create another force acting on the ball to affect the movement. So we decided to try it out. And this is just a peek at our lab a little bit. So we had this pneumatic cannon from Washington State University that we used to launch the balls. So it was really repeatable, and we launched balls at the exact same, from the exact same spot with the exact same spin axis, spin rate, and velocity. And all we changed was the seam orientation of the ball as we loaded it in, and we saw up to a difference of 8 inches in break. Okay, so we identified seam orientation that we thought would really work for us, and when we put it in one way, it led to 4 inches of additional downward break than gravity would have told us that we would have gotten. And when we did it the opposite way, that led to 4 inches of positive vertical break. So this was really eye-opening to us and proof that we were really onto something, because at the time, those of you who are familiar with the Rapsodo 1.0, you might recognize it in the back there on the tripod. So the Rapsodo 1.0, how it worked was it would look at how the ball is spinning and then determine how the ball must have moved as a result. And essentially, we proved that that isn't telling enough of the story. And it's not anything on Rapsodo, because for over 100 years, all we had known was that the ball spinning affects the movement. And it wasn't until my lab kind of identified that, that's not the only thing in play here. So this was really exciting for us, and it really showed that we need to pay attention to how the ball is oriented in order to really maximize our movement on pitches, which leads into seam orientation itself, right? So we're going to spend a considerable amount of time on this slide, but the Pro 3.0 is going to be the first ever practice product to provide seam orientation data to aid in pitch design. And what we're going to be providing to you, we're trying to make this as easy to use as possible, a lot of you are familiar with the user interface that we currently have, and we've always had the spinning ball animation, but that's always been in a 4-seam orientation. So some of you might have noticed when your pitcher's working on a 2-seam, it's still showing up as 4-seam, and that's just because that was just our default orientation that we had in the graphic. But moving forward in the Pro 3.0, the ball's actually going to be spinning in the correct orientation that we're measuring with our product. And then we're going to be showing that as well in a historical plot. And this plot is going to be showing the spin axis location on the ball in a latitude-longitude coordinate system. All right, so there's a latitude-longitude coordinate system that we're all familiar with, and that is the Earth. Right, you can identify any location on the Earth using longitude and latitude. And what's most important there is that you have a reference frame, right? So on the Earth, that's the equator, that's 0 degrees latitude, and the prime meridian, that's 0 degrees longitude. So in this plot here, you can kind of see where we've shown 0 degrees latitude and 0 degrees longitude on the baseball to be, right? And then the spin axis location on the ball is defined using that coordinate system. And what I mean by that, here I have a little prop that some of you may have purchased from Rapsodo at one point. It's basically just a rod sticking through the baseball. And this rod essentially is the spin axis, right? It's what the ball is rotating around. So what we're showing here is going to be the positive spin axis on the ball, which is going to be the point on the ball that the ball rotates counterclockwise about, okay? So that's how you're going to interpret this plot. And additionally, I know we don't have a lot of time today, so there's going to be a white paper coming soon that's going to go into a lot more detail on how to interpret these plots and how to understand this data. And we're really excited for that coming out. Additionally, if you have more questions, feel free and ask them at the end of our presentation or in the booth later on. All right, so this is the actual user interface we're going to have moving forward. So you can see the spinning ball animation up in the top right. It's on a loop, so we're going to watch it a couple times. But hopefully this is a good visual to show you what that latitude and longitude is actually showing. Right here, all right, here we go. So this is longitude, and then latitude, and then it's going to move the spin axis itself into the correct spin direction and gyro degree, okay? So you can also see down below the graphic there, it shows the actual numbers, right? The quantifiable numbers for latitude and longitude, and that's -3.2 and 43.4 for this pitch. So what's important for this, right, is that we're able to actually quantify where the spin axis is located on the ball, okay? Because we know that this affects how the ball is actually going to move. In my study, we showed that can be as much as an 8-inch difference in break, okay? So this is really going to add a lot to a pitcher's pitch design, which then leads into talking a little bit more about seam-shifted wake, right? I mentioned before that the forces acting on the ball directly affects how the ball moves, okay? For over 100 years, we've known that spin has a direct impact on how the ball moves. But my lab showed that, we really need to pay attention to the position of seams as well, because that introduces another force acting on the ball. While my lab, kind of coined this term and showed that this is what's going on, we're not ignorant enough to believe that pitchers haven't already known this, coaches haven't already known this, but we haven't necessarily understood the physics as to why that's happening. And as we do understand the physics better, then we're able to use it more efficiently and effectively, right? So the Pro 3.0 is going to be the first ever product to report seam-shifted wake break, which is going to be the amount of pitch movement that is due specifically to the seam-shifted wake effect, right? And this is made possible because of advancements in the Pro 3.0 that Brian already kind of touched on. So that is that we're seeing the entire pitch trajectory, right? And we're seeing how the ball is spinning because we're an optical system. So we're seeing how did the ball actually move and how was the ball supposed to move based on how it was spinning. And the difference between those is due to how the seams are positioned, right? Additionally, another advancement in the Pro 3.0 is that we're taking into account the atmospheric conditions into our spin break model, right? So that's to say we're taking into account elevation, temperature, pressure, and humidity, right? So pretty much everyone knows that balls move a lot differently in Colorado at Coors Field than they do in LA or any of the other, ground zero ballparks. And we're going to be taking this into account in our updated spin break model as well. And so we're really excited about these metrics because really pairing seam orientation and seam shifted wake break will help pitchers maximize movement, add additional movement more than they're already getting just based on how they're orienting the ball. Or also, some pitchers might not be able to spin it as efficiently as they as you may want them to, or as previous data has shown that they need to be spinning it in order to get that movement. But there are other ways to get movement, and that is because of seam shifted wake and paying attention to how we're orienting the ball in our hand. So we're really excited about these. So that's kind of the end of our presentation. We want to thank you all for coming out here. Happy to answer any questions. There is a mic that we've got to go around. If you have any questions, feel free to raise your hand, and we're happy to answer those.
Yeah, also, like I said, too, at booth 400, we are having a giveaway. So come check it out, 2.0 giveaway. So, and then also Sandy Alcantara this afternoon. So come see us at 400. But yeah, we're also happy to field some questions about, these new metrics.
Yeah. Hey, guys. Does the actual display on the 3.0 list the portion of the movement that is induced by seam shifted wake and the total overall movement, like your last slide showed, so you could see like what comprises each amount of movement, like that right there?
Yeah,
okay.
Yeah. So with the Pro 3.0, we're going to be showing the total vertical and horizontal break, and then the portion of that is due to seam shifted wake, right? So as you're working with your pitchers, adjusting the grips, pitchers have always been adjusting grips to kind of get the movement they want. We're going to be able to show you, okay, you're getting more seam shifted wake as a result, or you're getting less. So maybe you need to keep experimenting. And something that's really nice with the seam orientation, can go back to this historical plot. This historical plot's going to be able to show you, how well you can repeat those orientations and which orientations are getting you the movement that you want. Pitchers have always experimented. Usually they just jot down notes on what seems to work for them or try and describe how they're holding it in their hand. This plot and this data is actually going to be able to better quantify that for you, so you don't necessarily have to rely on just notes or feel.
Yeah, then also with that, one thing I think we've done well over the years is the immediate feedback. So John had talked a lot about that, but if you are working with a player to see if we, we're doing pitch design, when you hold your sinker in this way, how is it affecting break immediately? So you can then start to replicate that process to build out the arsenal. So that's a really important part of this, is all this new stuff is not something you would see after practice that day. It's immediately on the UI to be able to make those changes and build the best arsenal as possible with all these different arm slots, lefties, righties, for all the different variables in their pitching.
Yeah.
My question is, if you already have a Rapsodo certification in pitching, how will this new data be built into that certificate, or will we have to recertify?
Yeah. So for the certifications, they are still available. We'll continue to add to that. So this is really just brand new. So we do have the goal to add content on 3.0. Also, the seam shifted wake, seam orientation. I think the certifications do a very good job of like the overview of spin efficiency and what the 2.0 could provide. But we will be adding to those courses, and we'll make that very available once that's added into the certifications, specifically for these metrics. But also the white paper will be available. That'll be on our website. We'll make that available to explain these metrics as soon as possible through the white paper. So that'd probably be the first place to see that, would be at our website to understand the overview of seam orientation.
Yeah.
Over here, guys. So we know, every two pitches are not the same. Take a curveball, slider, whatever it might be. So how do you compare, if you're training seam shifted wake, how do you compare two pitches that are not thrown the same way? Can you do that? Is there a way to see the difference in those two and still continue to progress and develop?
Right. That's a really good question. And as far as seam shifted wake goes, right, it's due to a force that's acting on the ball. And that force is a function of things like velocity and spin rate and spin direction and gyro degree. And so, like you say, every pitcher is a little bit different. And so the same seam orientation might not work for two different pitchers. So they might need to make a little bit of adjustment. So it really is kind of an individual development, and hopefully this will be able to help you, keep track of the things that you've tried to get that movement, and show you exactly what movement you're getting as a result. And then as you're able to fine tune that, you can get to the movement that you're wanting.
Oh, okay, yeah. So the question was like for a pitcher having when utilizing different sessions, if they throw their curveball maybe like a different way when you're trying to find the best outcome. I think the best advice would be the different pitch design sessions. So in the older 2.0 apps, really the data kind of all was accumulated together. Our Diamond app allows you to pick a session type. So I think the best thing you can do is select pitch design and then maybe make a note too that today we focus on more 12-6, or hey, we were trying to get more of a sweeping pitch, or we messed with his grip, or even if it was an arm slot thing, that's where you can then right after, if they throw a 20 pitch pin with this grip, and then the next bullpen they try a different grip, you can then evaluate those right side by side because we know what session that was and what date. As the coach, then you can evaluate, hey, what is playing better? That'd probably be the best ways to utilize our session types.
Okay, yeah, so we had a previous question about how soon the white paper will be available. So all of the text for that is completed. So our marketing team is just working on making that look really pretty and nice with some nice graphics. So yeah, we're expecting that to be coming real soon in the next couple months.
Yeah, so we're excited that the 3.0 is live and available now. It came out just recently. So the Pro 3.0 is available. We're demoing it in the booth, so come see it. But we're actually even able to take orders here for anyone interested in the 3.0 now. We just launched it towards the end of last year.
How do y'all determine the atmospheric conditions? That's just an interesting one. Is it based on your location that you input in the app, or?
Yeah, so that'll be a user input as far as elevation and temperature goes, and humidity, and you're gonna be able to save that location so that you don't necessarily have to input it every time. For example, if you have an academy or something, you're gonna be using it in the same place every time, so the elevation isn't gonna change. If it's indoor, the temperature and humidity probably isn't gonna be changing either. So you can save those, and yeah, that's how we're gonna make sure that that then gets taken into our algorithms correctly.
All right, yeah, thanks again, and come see us at booth 400. Happy to dive into any deeper questions with John and the team over there. So come see us at 400. Thanks, guys.